Okay, so today we're going to be taking a look at seasons. I wanted to draw this with you because I feel like it's just much easier for us to do that. So what we're going to do is we're first going to put the sun in the middle of our diagram, like so. Right, and then we're going to draw the orbit of Earth going around the sun. We know that the orbit of Earth is elliptical. And in truth, we've talked about this idea that the sun is actually a little bit off-center to the Earth, but that's okay. So what I'm going to do is I'm going to draw the Earth in 4 positions. I'm going to draw it here. Oops, that's not what I wanted to draw. We're going to draw it here. We're going to draw it here, here, and here. Now, there's 3 reasons that we have seasons on Earth, okay? And the distance from the sun has nothing to do with it. The first reason is because the Earth is tilted on an axis. So instead of the Earth looking like that, right? Instead, it's tilted on an axis like this. Now, because it's tilted, that means that some parts of the Earth sometimes lean more towards the sun, and at other times, some parts of the Earth lean away from the sun. So for example, look, I'm going to draw in that tilt on each of my diagram of Earth, and I want you to also notice that the tilt is always the same. Okay, that is called parallelism. One of the reasons that I posted in the notes is the parallelism of Earth's axis. That parallelism means that in each position, Earth's tilt is always pointing in the same direction, and interestingly enough, it's actually pointing at the North Star Polaris. So that's the first thing. Okay, the other thing is that Earth is moving around like this, right? We're revolving around the sun over the course of a year. We're moving in that general direction, as you can see based on the arrows that I drew. And I'm going to just draw in the equator at each time here. Okay, remember the equator is the line that goes down the middle of the Earth. What I'm noticing here, now this is a little exaggerated, but I'm going to just draw in what I'm calling the direct ray from the sun. The direct ray is the place that at noon, the sun is 90 degrees above the horizon at that place on Earth. Okay, so look, if I draw a direct ray, it hits very much so in the northern hemisphere on that date. Right? That same direct ray hits in the southern hemisphere on that date. But at these 2 dates, it hits directly on the equator. So that's why we have seasons, because sometimes the northern hemisphere is tilted more towards the sun, allowing us to get more light there. So that would be summer for us, right? At other times, like here, the southern hemisphere is getting it. So for us, okay, for the northern hemisphere, this would be June 21st, right? The first day of summer, right? This would be December 21st, the first day of winter, all right? Then these would be, so if we're thinking logically, we're going from June to December, so this must be fall, 9/23, and this would be 3/21, which would be March, as we're moving along. That's the basics, but there's some other interesting consequences that come from this as well. One of them is the fact that at certain times of year, we get, no light at certain places. So for example, look, if I am, let me just change my color here. If I am at the North Pole on this date, no matter how much I rotate, I'm never going to get into darkness. Right? So on the first day of summer at the North Pole, there's 24 hours of daylight. On the other hand, if I'm at the South Pole, I'm never going to rotate into daylight. The same is true but opposite on December 21st. South Pole gets 24 hours of daylight, and the North Pole gets no hours of daylight, 0 hours of daylight. If you notice on these pictures, it's harder to draw accurately here, but if it was drawn to scale and perfectly, you would actually see that on March 21st and September 23rd, everyone gets 12 hours of daylight. So 12 hours of daylight on these 2 dates at the North Pole, and then 24 hours here, 0 hours here, 0 hours here, 24 hours here. So it really depends on the time of year and what's going on. That changes how much sunlight we get, okay, with latitude. So that's the basics of seasons, guys. I just wanted to show you that. I'm going to show you another video in a minute that will go more into the sun's path and how it changes with location on Earth. So I'll show you that in a minute.